Welcome to Math 1033 Galaxy and our superheroes fighting the final exam review. Questions 1 through 30 have joined forces forming an undestructive allied squad called the final exam. The evil cannot win, not when the two most powerful superheroes are on call. Dagger equation slicer Diana, which is me, and my sidekick Velectra, which is Vanina, never sleep. Fighting one common enemy, the final exam review, we will solve each problem and find the correct answer. We will put away this final exam squad for good. This fight might last for about 2 galaxy hours, but it's definitely worth it to watch. If you would like to join our forces and have any questions, you can punch in your question into the text box, but don't use your full power to not leave serious damage on your keyboard. No question will be left unpunished and solved by my sidekick Velectra and myself. So I hope everybody can hear me loud and clear. You may raise your hand if you can hear me, so we know that we can start. Okay, I see some hands raised. Let's go to the next slide. This is me, Dagger equation slicer Diana, and here is Velectra Vanina. And we're starting with the first question, which says, use the square root property to solve the equation. So square root property, that's a hint right here. Oh, sorry. I forgot to change to my pen. We haven't done this in a while. And I'm not sure if red is a nice color, so let's change to black. So right here, square root property, which means we need to get the term or variable with the squared all by itself, and then we can apply the square root property. So first of all, I'm going to move the 4 to the other side, and then I'm left with 8x squared. Right here, this is going to cancel out, and 132 minus 4, that should be 128. Okay. So my squared term right here is still not by itself. I have an 8 in front, and this indicates multiplication. So I'm going to do the opposite and get rid of this 8 by dividing both sides by 8. This is 1, or just x squared, and 128 divided by 8 should be 16, if I'm not mistaken. All right, so now I got my x squared term all by itself. I can apply the square root property by square rooting both sides. And remember, when you're using this property, you're going to get a positive and a negative answer. On this side, the squared and the square root are canceling out, and I'm left with just x. This is what I wanted. And on this side, I'm going to have my plus and my minus, and the square root of 16 is just 4. So my final answer is x equals positive or negative 4. And in your packet, this is answer choice B. Are there any questions on how to apply the square root property? All right, then we're going to move on to my next villain, question number 2. This question asked me to solve the equation, but this time, instead of using the square root property, I'm going to use the method of completing the square. I want you to understand that All these methods are just different ways of doing the same thing. And depending on how the equation is set up, you will have to learn to decide which method is easier to use. But at the end, you should get the same answer no matter what method you are using. So completing the square. For completing the square, I only need this part, and I'm going to get rid of this part of the negative 21 by moving it to the other side. Also, the coefficient of the square term should be an imaginary 1. In this case, we don't have a number in front, so we don't have to do the step, but if there should be a number, you also have to divide by this number to get the x squared term by itself. But back to this problem, let's move the 21 to the right side of the equation. The goal of completing the square is to create a perfect square trinomial. So let's rewrite x squared plus 4x. My 21 is gone, and this is equal to 21. 0 plus 21, 21. Now I need to know a little formula, which I'm going to write on the side, and you might want to memorize it for the final exam because you will need it, which is b over 2, and that's all squared. Remember, your equation usually, as it is up here, comes in the form ax squared plus bx plus c, which indicates the number or the constant, is equal to 0. And then the letters in the formulas that we are going to be using today are these numbers that are in front of the variables or the constants. So in our formula, we need the b, and the b in our original equation is 4. So we're going to plug 4 into the formula, and that's over 2, and all this is squared. When I solve this, 4 divided by 2 is 2, and 2 squared, so 2 times 2, I'm going to get 4. So now my 4, I'm adding to both sides of the equation. I have to add it to both, so my equation is still the same. Oops, not equal to. Let me get an eraser real quick before you guys noticed. That was that evil villain getting in the way. Okay, back to my color. So I said adding, and that's what we're going to have to do, add 4 to both sides. So now let me just rewrite x squared plus 4x plus 4, and on this side 21 plus 4 should give me 25. So this part here now is a perfect square trinomial if I did it correctly. So then I know perfect square trinomials, I could factor them like this. My x, if the middle sign is positive, there's a positive sign, and then which numbers multiply to give me which of the same two numbers multiply to give me 4 and add to give me 4, that would be 2. So this would be my perfect square trinomial in factored form. And on the other side, I have 25. Now I'm ready to apply the square root method. I could square root this side, and I also have to square root that side, which gives me a positive and a negative answer. And on this side, my square and my square root cancel out, and I'm left with x plus 2. And on this side, I'm still going to have my positive and my negative, and the square root of 25 is 5. So the goal is to get x by itself. I have to move the 2 over. I'm going to subtract 2 from both sides. So x is left. And over here, remember, you have 2 different versions of the answer, which means one time we're going to have a positive 5 minus a 2, and then we're going to have the version of a negative 5 minus a 2. So 5 minus 2 is just 3. And my second answer, negative 5 minus 2, is negative 7. So in my packet, that answer choice is D. Yay. Okay. 2 variants down, and next one to go. We did a great job here. Super. Question number 3. So this time we're doing the same thing. We're solving a quadratic equation, but this time we are going to use the quadratic formula. And this is another formula that you will have to memorize. And this formula goes, the x value, you can find that by using negative b plus minus the square root of b squared minus 4ac, and all this is over 2 times a. Okay, and remember this is representing my a, my b, and my c as long as the equation is set equal to 0. Okay, so I'm going to use my formula and I'm going to plug in my values. X equals, I have a negative b, so negative is from the formula and my b is 10, then plus minus b squared, so 10 squared minus 4 times my a, which is 4, and times c, which is 2. All this is over 2a, so 2, and my a is 4. Okay, we plugged everything in. Now we just have to solve. We start with all the things that are under the square root. So I'm just going to copy the first part down, negative 10 plus minus, and then 10 times 10 gives me 100, and then negative 4 times 4 times 2 gives me 32. My sidekick says it's 32. I hope this is correct. I cannot afford to lose this battle. I'm very competitive. Okay, so this is what we get here, and we also can do already our denominator, which is 2 times 4. I know this one, 8. Okay, keep on simplifying. Negative 10 plus minus 100 minus 32 is 68, and then over 8. Okay, I know that 68 is not a perfect square root, but we always have to check if we can simplify it by finding 2 factors of 68 where at least one of them is a perfect square. And in my case of the 68, I can think of 2 factors of 4, because 4 is a perfect square, and 4 times 17 would give me 68. So I can split up the 68 into 2 factors where one of them, in this case the 4, is a perfect square root. Okay, so now I can take the square root of 4, negative 10 plus minus, which is 2, and then I have left the square root of 17. All that over 8. My last step is, because this is basically a fraction, and fractions we always have to check if we can simplify or reduce. So right here I see 10, 8, and 2, and they all share a common factor of 2. So I could reduce this by dividing each term by 2. This leaves me with 10 divided by 2 is 5, plus minus 2 divided by 2 is 1, but I still have the square root of 17, so I don't need to write the 1. And 8 divided by 2 is 4. This should be my final answer. There's nothing else I could simplify or reduce. And if I look at my packet, this is answer choice C. All right, nice. We beat another billion. Let's move on to question 4. All right, this one says perform the indicated operation, and we have to write the result in the form a plus bi. Okay, so when you're having I in the equation, especially when it's a fraction, you should not have it in the denominator. And the method that we're using to get rid of I in the denominator is multiplying top and bottom by the conjugate. So the conjugate of 5 plus 4i is 5 minus, just change the sign in the middle, minus 4i. But what we do to the bottom, we also have to do the same thing to the top. And that leaves us basically with two foiling problems because this is multiplication. So FOIL the top, 4 times 5 is 20, and then 4 times negative 4i gives me negative 16i. 8i times 5 is positive 40i, and 8i times negative 4i is negative 32i squared. I times I squared. Okay, before we simplify on top, let me do the bottom as well. So 5 times 5, another foiling problem, is 25. And if you've been doing these a lot, you actually notice that the middle term cancels out, and instead of using FOIL, oops, wait, where does the F go? F, O, oh, there goes an I, IL, you're only using the F and the L. So 5 times 5, the first was the first, is 25, and then the last times the last, which is negative 16i squared. If you don't believe me, you can do the whole FOIL, but I promise you in your next step, once you simplify, you will end up with the FL, with the first and the last terms. Okay, another thing that we need to know for this problem is what is I squared? So if you've done the sections already, type in to your box, punch it in, what is I squared? It actually gives you a number, a value. All right, I got an answer here from our online supporters and superheroes wannabe. So let's see if they're going to graduate by the end of this superhero course. Negative 1 is the correct answer. I squared is equivalent to negative 1. So everywhere where we have an I squared, we can switch this out and put a negative 1. So let me rewrite the top, and as well I'm going to combine these two terms because they are like terms. So I have a 20 and then a positive sidekick, help me out, 24, 24i, and right here negative 32, instead of I squared I can multiply this by a negative 1. Bottom, same thing, 25 minus 16, and instead of I squared I can multiply by a negative 1. All right, so now let's just combine like terms on top. So we have right here negative 32 times negative 1 is just a positive 32, and 20 plus 32 gives me 52. In the bottom, right here, negative 16 minus 16 is a positive 16, and 25 plus 16 should give me 41. Oh yeah, I'm leaving something out. Okay, so right here, I cannot forget about my 24i with the same common denominator. So I just split it. I could have also left it with the same common denominator, but sometimes there are things you can simplify, so when you split them up, you actually notice if there's anything you can reduce. You can reduce fractions by. So either one of these answers is correct. You probably have to look, because you're dealing with multiple choice, which answer would apply in your case. And if I look at the packet, actually they want it in the split form right here. So this should be answer choice A. Nice job. Questions? Electra? Vanina? Electra? No questions? Okay, we're moving on to the next billion. Okay, we are not quite done with solving quadratic equations yet. There's another one, and again, they want us to use the quadratic formula. I'm not going to make you guys punch it into your keyboard because it's kind of difficult, so I hope you remember. X equals negative b plus minus b squared minus 4c, 4ac, sorry, and all that over 2a. So every time I use a formula, I rewrite it so I memorize it. So let's plug it in. X equals, right here is my A, B, and my C because it's set equal to 0. So my B is 14. I have a negative from the formula, negative 14, then plus minus B squared, 14 times 14, that would be a sidekick. Can you do some punching for me? 196. So I'm solving the 14 times 14 already, which is 196. And then minus 4 times A, which is 1, and C, which is 53. And all that is over 2 times A. My A is 1, so just 2. Now let's simplify under the square root. Negative 14 plus minus. Sidekick, what is 196 minus 4 times 53? Negative 16 is what we get under the square root, and in the bottom we have a 2. Okay, so when we are dealing with negative square roots, we should know that we will get an I out of it, because you cannot take the square root of a negative number. If you try to punch that into your calculator and solve that, you probably try that sidekick. I think you're going to get an error message and tells you to quit or something. But no real answer. There we go. But what you can do is you can split up these two into negative 1 and just a 16. And then you should know that the square root of negative 1 is nothing else than I, and the square root of 16 is just 4. And we can obviously rewrite it, because in math you always like the numbers first and then the variables or letters. So that whole thing, the negative 16 under the square root, comes out to be positive 4i. So now let me put that into the problem. Plus minus 4i over 2. So if you check out this problem, you should notice that you're not quite done, because if you look at 14, 4, and 2, you should realize that they all share a common factor of 2. You have to reduce everything by 2. 14 divided by 2 is just 7, plus minus 4 divided by 2 is 2i, and 2 divided by 2 is just 1. So actually I wasted the 1 because I don't really need it. So this should be my answer, and I believe this time they wrote it like this, which is fine, to write it in set builder notation and split up the two versions of the answer, and the negative 7 plus 2i. And that is answer choice C. Alrighty, I'm gonna hand over now to my sidekick Electra and let her do some work too, because being a superhero is not as easy as it looks like.
Okay, I'm ready to start and kick some problems' butt. Can I say butt on live TV? Maybe not. But, okay. All right, so let's go ahead and slide to the next slide. All right, finding the power of I. What can really help you when you're finding the power of I is to memorize these four little, I don't know, notes. So I is just I, so, but I to the second power we already know is -1. I to the third power is -I, and I to the fourth power is 1. And I'm stopping right here. I don't need to go any further. So if I'm trying to find I-36, this only means that, for example, it repeats every 4, like I to the 8, I to the 12, and so on and so forth, like multiples of 4, they'll all be 1. Multiples of 3, they'll always all be -I. So if I'm trying to find I-36, all I need to do is find out how many times 4 goes into 36. It's a 4, which means it goes 9 times, right? It goes evenly, so I have a remainder of 0. So if I go 4, 8, all the way to 36, that means that I-36 is equal to just 1. If I had a remainder, then I had more work to do, but this is fine. Any questions? No? Okay, so I'm going to move on to the next slide. Next question. Okay, now we have the square root of a negative number. We cannot have a even index and have a negative number inside. That's a not real number. But like we said before, we can split this into square root of -1 times the square root of 184. Square root of -1 is just I. Oops, I meant 4. How did I? Okay, out of the picture. Yes, that villain. Always trying to steal my numbers. 184. What? Okay, so now I'm going to break down 184, and I know it's divisible by 2. When you're not sure which other two numbers, if it's even, 2 will always work. So 2 goes into 184 92 times. Going to break down 92 into 2 and 46. And 46 is 2 and 23. Okay, so now I have that 184. It's 2 times 2 times 2 times 23. And if I find, if I find 2 of the same, since I'm looking for a square root, that comes out of the radical. So now I have 2, the I that was already there, and inside I was left with 2 times 23. I cannot bring the 2 out or the 23 because they don't have a companion. Let's put it that way. So I just multiply them back. So my final answer is going to be 2I 46, which in your packet is answer choice B. By the way, the last one was answer choice D. Any questions? Christine? Nothing? Okay. That's a good sign. That means you get it all. So I'm going to go to the next slide. Okay, I'm finding the function value. Okay, so as you see here, it says f of x, and here it says f of 7. So basically, all they're asking me is to substitute this x for 7, meaning every time that I find an x on my function, I'm going to substitute it for 7. So then I'll have 7 minus 4 over 12 times 7 minus 10, leaving me with 7 minus 4 is 3. 12 times 7 is 84 minus 10. So now I have 3 over 74 as my final answer, meaning that when x is 7, y is 3 over 74. And that is answer choice B on your packet. Any questions? I don't hear anything, so I'm going to move on. Oops, what did I do? Where is this slide? Oh, that's, what was your superhero name? Something Slicer? Boyfriend. Equation Slicer boyfriend. Okay, next slide. Question 9. Okay, for this one, I would like to use, I wanted to use the calculator. Do I escape? Okay, all right. So basically what are we doing here is we have this function, and in order to graph it, we need to plot in some points. I'm going to come up with some points. Okay, so all right, so I guess I'm going to choose -1, 0, 2, 4, and 5. That should be enough. And according to my calculations, which I did secretly, I'm not going to reveal how, I'm going to get, okay, now I'll show you. No, we don't need the calculator. It's fine. It's my secret weapon. Okay, I'll show one. All you need to do is plug in x here, and then you get what's your y value. Like, for example, when x is -1, I'm going to have -1 minus 2 raised to the third power, which means -1 minus 3, minus 2 is -3, and -3 to the third power is -27. Yes. Okay. So that's why I'll put here -27. That's a very big value. I don't think we're going to use that because I don't have enough space. But the 0 should do the trick. 0 and the 2 and maybe the 4. I'm probably just going to use these 3. No. So the second one, are you going to tell? Okay. So let's use the calculator. Yes. Okay. Whoop. Keep. Okay. So my calculator is right over here. What you can do is you can go to your y equals and punch in the equation, the function that you need. In our case, we had, I'm going to open parenthesis, x right here, minus 2, close parenthesis. You can use this caret here to raise it to the third power. Okay, and then let's just graph it to see how it looks. Okay, it's going to look like this because the basic function for an x cube is this wiggly vertical line. Now, what you can do is if you press second graph, it already had values on it. Give me just a second to take them off. Okay, all right, so this should be clear now. I'll go back to second graph. Now I don't have anything, and then I can punch in some numbers. So I think I had, what was it, 0? When x is 0, my y is negative 8. When x is 1, press enter, my y is negative 1. I'm going to try 2. When x is 2, my y is 0, and I'm going to just do one more. When x is 4, my y is 8. Okay, I'm going to go back to my PowerPoint and plot in my numbers. So I had, okay, so I got for 0, I had negative, oops, sorry. I have, yeah. See, us superheroes, we are old school. There's no such thing as these stuff that you guys have now. Ink, these gadgets. Okay, 0, I got negative 8. For 2, I had 0, and for 4, I have 8. So I think these three are enough for me to make my graph. So 0, when x is 0, y is negative 8. So 5, 6, 7, 8. So somewhere right here. Then I have when x is 1, 2, y is 0. So right over here. I may want to get one more point. I'll look. And when x is 4, y is 8. So 10, 9, 8, 1, 2, 3, 4. So over here. Okay, I guess that's enough. Or should I pick one more point? Yeah, I guess that's enough. So it's going to look something like, whoa, definitely not. Wait, let's try this again. Yes, I'm getting in that shape. Yeah. Okay, you get the point. If you look at the graphs that you have in your packet, it's letter C, and it kind of looks like this. It's a squiggly line. I obviously. Okay, so let's see. We got here 0, negative 8, right? We have here 2, 0, and we have 4, 8, right? Definite match. All right, anything? Um, you're so welcome, Christine. I've been dying for a feedback. We get lonely as superheroes. People only need us to fight crime, and that's it. Okay, so let's go to a next question. Okay, finding domain. Every single time that you ask to find a domain for a function and the function is a fraction, your first step is to set the denominator equal to 0. We do not care about the numerator. We just get the denominator, whatever you have down there, and you set it equal to 0. Then you solve for x. Negative 7, I got to subtract 7 from both sides because I'm trying to have x by itself. This cancels out, so I get negative x equals negative 7. And since we have that imaginary 1 here, I'm trying to get rid of it. I'm going to divide by negative 1 on both sides, so I'm left with positive 7. This only means if x was 7, this denominator would be equal to 0. And what we would have something like this, 2 over 7 minus 7, make it 2 over 0, which makes it undefined. And that is exactly why the domain has to be all the numbers but 7. And if you're writing that on an interval notation, we'll have all the numbers from negative infinity to 7, but we're going to exclude 7 by putting parentheses, and then we're going to union that with starting with 7 again. We exclude 7 by using parentheses, and we go to positive infinity. That way you got all the numbers from negative infinity to positive infinity, but you excluded 7. The reason you excluded 7 is because if x is 7, it makes this function undefined. Okay, and that is answer choice D on your booklet. Okay, I'm gonna turn over to dagger equation slicer Deanna. Kapow!
All right. I regained my powers. I think I'm ready now for another session of superhero fighting. Let's go to the next slide. This is about graphing. So let me just prepare here. Okay. So it says graph the function by starting with the graph of the basic function. So in your packet you actually see the basic function, and here too this is the basic parabola function. And then using the techniques of shifting, compressing, stretching, and or reflecting. So it is good to know, first of all, what are the basic parts of this equation. For example, this last part tells you with a parabola if the parabola is shifted up or down from its basic function. And then this number here tells you if the parabola is shifted right or left. And then usually, or it could happen that there is something in front of here. This, in this case it's 1. This one would tell you if it's stretched or reflected. If it's a negative, for example, it would be reflected across the x-axis. So instead of an opening up parabola, you would have a opening down parabola, like this one. Okay, if that was a negative here in front. Okay, so the basic equation of a parabola would be fx equals a, and then you have your x minus h squared, and then plus k. And the h and the k in this case, it's a coordinate, and that would be the vertex, which means the lowest or the highest, depending on how the parabola looks, point of the parabola. So in this case, so right here from our basic function, that h and the k would be 0, 0. But in our case, this parabola is shifted. So I usually like to start with this last part, which tells me if it's shifted up or down, because that's the easier one. I don't have to think nothing. I just take this number, and this will be on the y-axis. So the basic parabola is shifted 7 units down on the y-axis. 1, 2, 3, 4, 5, 6, 7. So now the vertex is right here. It moved from here to here, 7 units down. And then, as you can tell, the formula right here has a negative. So if the formula has a negative, then the actual number that's in our equation, the 4, is just 4 and is positive. So with this one, you have to be a little bit careful because it's always the opposite. So instead of being tempted to move to the left on the x-axis, right or left, so left because negative, you have to do the opposite, which means you moving 4 units to the right. So right here, 1, 2, 3, 4. So my vertex of the parabola moved 4 units to the right. Remember, because of this, because the negative is part of the formula and does not belong to the actual h value, you have to move to the opposite direction, which means to the right. It's a positive 4. So now my parabola should look like this, and I'm not doing much better as my psychic. I think we need to practice drawing a little bit better before our next session. So let me try this one more time in a different color. I know I can do it. Okay, 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 okay. Yay. Doesn't that look much better? So if you look at your packet, you don't even have to check anything else because it is obvious that answer choice, dang it, I'm going to have to look in the packet now. 11 is D. So if you look at your packet, this is the only one that will match the D version. The other ones are either up here or upside down or do not have this point, which is 4, comma, -7 on the coordinate system. Are there any questions, Electra, before I move on? This is like a different concept, so let's move on to the next one. This question, a word problem. I know many of you, just because they see a lot of words, they're already shutting down. Don't shut down. If you have to, just read them multiple times. It will get better each time you read it. And at the end, if you do a bunch of them, you realize that the wording might be different, but the steps you have to do to solve them are always the same. So let's just read it. The number of mosquitoes, M of X, in millions in a certain area depends on the June rainfall, X. So the rainfall represents the variable X in inches. This is our equation, mx equals 14x minus x squared. And now the question is, what rainfall produces the maximum number of mosquitoes? So there are different ways of solving that. First of all, let me write down the most important information, which is the equation. This is the equation to find out how many mosquitoes were produced in a certain month of rainfall. So 14 x minus x squared. As you can see, this equation is of quadratic form. It has a squared, so that means it's going to give me a parabola. I can write it in the quadratic form by just moving those two terms around to have my ax squared term in front and then my b term. So nothing changed. I just switched them around. And then I can apply my vertex formula. We're basically looking for the point that's either the highest or the lowest. In this case, as you can see, there's a negative in front. That should tell me that I'm going to have a maximum. The parabola going to look like this. So right here, so we can use the vertex formula to find that highest point mathematically. And the vertex formula to find the x value, or in our case the vertex, so we don't get confused, is like to be called the h value of the vertex, and the formula is -b over 2a. So we just have to plug in our values. Right here would be our a value, and this is our b value. So for b, we plug in -14 over 2 and then times a -1. And if we solve that, we should get 7, a +7. So this would be my maximum x value. Now let me see if my question is looking for the x value or the y value. So it's looking for the number of mosquitoes, maximum number of mosquitoes. So my X value actually represents the mosquitoes. So I should be done. And if you look in your booklet, that should be answer choice D. If by any chance you cannot remember this formula, let me highlight it in a different color, in red. This formula to find the maximum or the minimum, the vertex, basically the X value, you can also graph it. And if in the question they're actually asking you for the corresponding Y value or talking about the vertex, the K, then you can plug in your X value back into the equation for every X to find the corresponding Y value or K value. But if you prefer to graph it, let's go to our graphing calculator. Okay, keep the ink. Go to the calculator. Let's delete fast what is in there already. So we have our equation, and it doesn't matter if you plug it in the correct form of the ax squared plus bx plus c or the way that you're being given it. It doesn't matter. You still get the same answer. So 14x minus x and then squared. And then if you are graphing it, if I'm lucky, it's going to be there. So I'm not lucky. As you see, it doesn't show me the entire parabola. I'm going to have to see a little bit more of the positive y-axis. I can go to Window, and it lets me change the axis there. So I notice I need a little bit more of my positive y value. I can change this from 10, let's say 50. And now I'm graphing again to see how it looks now. The key thing is I need to see this top part because that's the maximum I'm looking for. So now I see it. I can adjust it a little bit more if I have to by extending the x-axis. I can also change the scale by what is counting. Instead of counting by 1, I can be counting by 5s. And this one too, I can be counting by 5. So now the tally marks are a little bit more stretched out. So here you go. You see the parabola, and we're looking for the maximum. So to find the maximum, you would hit second, the blue button. Then you see how it says in blue up here, calc. And then number, we have a maximum. So that will be number 4. Or just use the cursor to go down to number 4. It asks you for the left bound of the parabola. So make sure that you are on the left side of the maximum. It doesn't matter where you are, just don't try to be figuring out where yourself, where is the top part. Just be a little bit more on the left than necessary. Then hit enter, and it will ask you for the right bound. So move all the way over to the right side of the maximum value or bound and hit enter again. It asks you to guess, so last time enter, and then it actually spits out the values. So it gives you the x value of the maximum of the parabola, which is 7, and the y value, the corresponding y value, would be 49. But in our case, because we were asking for the number of mosquitoes, the x value would be the corresponding answer to this problem. So let's go back to our slide, from current slide right here. So mathematically or graphically, it's your choice because it doesn't really indicate what you should do. Questions? Okay. Another graphing question. So this one says determine whether the graph is the graph of a function using the vertical line test. So to determine if any graph is a function, you can use the vertical line test by drawing vertical lines. And then the vertical line test says, and we already know we are not pretty good with drawing vertical lines here. Oh my gosh. Okay. I feel like in kindergarten again. So okay, you get the you get the deal. Oops. So you can draw vertical lines or you just draw them in your mind. What happens is you can only cross your graph, so your function, in this case this line, once. As soon as it crosses twice, it's not considered a function anymore. It can only cross once. So every line I draw, if you noticed, it only crosses my function once. So because of this, this graph is considered a function. Function. For example, if you have a graph that looks like this, and this gonna and then you draw your vertical lines. So now you can tell that the vertical line crossed the graph twice. So this graph is not considered a function, not a function. Just for you to see the difference, because you never know which version of the problem you will get on your final exam. So in our case, question number 13 was a function. It's Vanina, what is it on the packet? A or B? It would be B. A function. B. Okay, moving on to question number 14. Find an equation of the line through the pair of points and write the equation in standard form. So here the standard form is given ax plus by equals c, and we are given 2 points. So as soon as we are given 2 points, and that has to do with linear equations, we should come up with this formula, this slope formula. M equals y2 minus y1, all that over x2 minus x1. And then we can label our points. This could be my first point, so x1 and y1, and this could be my second point, x2 and y2, and then I'm going to plug in my values into my formula to find the slope, because that would help me to write the equation of the line in either standard form or in the slope-intercept form. It doesn't matter, but if I'm given 2 points, this is the formula that I will have to use. So m equals my y2 is 3, my formula says minus, and then my y1 is negative 8. Then my x2 is 0, and my formula says minus, and my x1 is 4. I simplify this, and I'm going to get 3 plus 8, negative 4, and that is 11 over negative 4. I think I made it. Did I make a sign mistake somewhere? No? You sure? I think I did. Look in the packet. I think this is supposed to be a negative here. Can you look quick? Because I don't remember this answer. This is number 14. Did you guys notice if there's a sign mistake compared to the packet that you were supposed to print out? Question number 14. Who is faster, my sidekick Fanina or you? Because if you are faster, you're definitely on the team, and the lecturer is going to be off the team. It's a negative 3, right? Okay, so on your packet, that is the correct number, but I guess when I created the PowerPoint, I forgot this little negative. So let's just go back and add the negative here, and then instead of getting a 11, I should be more getting a 5. And now it sounds familiar. So we found the slope. We found the slope of our equation. Now we can use the slope, the point slope form of the equation, which is another formula or something to memorize. Let me use a different color, which is y minus y1 is equal to m x minus x1. So we can use this point slope form of the equation to get to the standard form. Plug in the values. But for my y1 and my x1, I'm going to use this point, and for the reason that this point looks easier to me, and which means less to calculate, I can use either one of the 2 points, but I need to use the x and the y value from that point that I'm choosing. So y minus, and my y1 from the second point is -3 equals my m. I found my m, which was -5/4, and then x minus x, and in this case x is 0. So I want it in standard form, which means the variables on the left and the constants on the right. I'm going to combine these two signs, which leaves me with y plus 3, and then I distribute, and the 0, I can drop the 0, it doesn't really mean anything. So -5/4x. Again, I want constants on the right and variables on the left. I'm going to let me just rewrite the problem because I'm running out of space here. I'm going to subtract 3 from both sides, and I'm going to add 5/4 on both sides. Add 5/4 x on both sides. Okay, cancels out, and I'm left with 5/4 x plus y is equal to -3. Okay, you might not going to find your answer in the packet yet, because usually in standard form they do not like fractions, and the method of getting rid of the fractions is by multiplying through by the denominator, or least common denominator, but in this case I only have one, so I have to multiply each term by 4. Each term right here and right here. I'm going to multiply. So when I multiply the first one, the denominator cancels out and I'm left with 5x. Multiplying the 4 times the y gives me 4y, and multiplying the 4 times the -3, I'm getting -12. So if you look at your packet now, you should be able to find your answer, which is D. Okay. Pow! There we go. That was a tough one. That's how I feel right now. Okay. Another one of this section. In this case, it wants us to write an equation of the line given this following properties. And this time we want the equation of the line in slope-intercept form. So right here is the slope-intercept form of an equation. And this equation goes through this point and is parallel to this line. Okay, because this is already solved for y equals mx plus b, I know that my slope is right here in front of the x term, so it is 4. And then I need to know the condition of two lines that are being parallel. Two lines that are parallel, they actually have the same slope. So for my new line, the slope should also be 4. You could also get the version of a perpendicular slope. Do you remember perpendicular? Do you remember how you can convert the slope of a perpendicular line? Type it into your answer box. What would be the slope if the question was asking for a perpendicular line? It would be the opposite reciprocal. Opposite, and then reciprocal. Okay. The opposite determines the sign. So if you had a positive, it should be a negative and vice versa. And reciprocal just flips the number. So in this case, it's 4 over 1. So flipping it would become 1 over 4. So that would be a perpendicular. But in our case, we were asked parallel, but I just wanted to make sure you also can get the version where it asks you for a perpendicular line. So parallel is the same. We can either use our point slope form again, which is y minus y1 equals mx minus x1 to plug in our known values. So we have our point right here, x and y. So y1 would be 4 equals then our slope of a parallel line. So the same slope would be 4. And x minus our x value is 8. Solving for y, we are getting, use distributive property for x minus 32, and then bring this over to the other side to get x by itself. Y equals 4x, and add these together should give you 28. And this is answer choice D. Okie dokie. Now my sidekick Electra is coming back on. We're switching, so the work is not as tough. And this is the next question.
All right, so let's get right to it. Question number 16. We're multiplying binomials. Okay, what we're going to do is the old FOIL, but basically it's just the first one times the first one, and then again the first time times the second one, the first one times the second one. So 4 times 7 is 28. 4 times positive 6i would be positive 24i. Negative, now we do the second one times the first one, and the second one times the second one again. So negative 7i times 7 would be negative 40. That's a 4. Okay, let me fix it. It's weird. It's a very weird 4. Obviously, I was trying to put a different number. Okay, so where were we? Negative 7i times 7, which is negative 49i. Then we have negative 7i times 6i. So negative 7 times 6 is negative 42. I times I is I squared. Okay, let's see what we can do here. We can combine these two because they are like terms. And I get that 24 minus 49 is negative 25i. And minus 42, I squared is negative 1. A little bit too late. Thank you. Slice and dicer, Deanna. Okay. Okay. And I gotta do these two first. So I get that negative 42 times negative 1 is positive 42. I'm just gonna copy everything else down. 25. And my next step, oh, like terms right over here. And 28 plus 42 is actually 70. I'm gonna write this first, even though it would really not matter that much because they didn't specify how they wanted the answer. I could have left it like this if I wanted to. Okay, so in your packet, that's answer choice D. Any questions? Do I have any questions, Deanna? Okay, I'm gonna move on then. Actually, let me give you about 2 seconds. 2, 1. Okay, I'm moving on. Oh, there we are. Okay, finding the domain. Again with the domain, again with a fraction. Every single time. I cannot stress this. You got a fraction. You ask to find the domain, it's have to be to get the bottom part, set it equal to 0, and solve. Now this one, it looks to me like the best way for us to solve it, since we have a trinomial, coefficient, leading coefficient 1 is to factor it. So first step, open 2 sets of parentheses, split my x's between each parenthesis, bring my first sign down, negative times negative gives me positive. That's how I figure out my signs. I need factors of 27 that give me 6. I'm going to cut through the chase is 9 and 3. The bigger one goes first. The smaller one goes next. Now, if I was just factoring this and there was no such thing as equal to 0, I would have stopped here. But I actually have this, so I have to apply the zero product rule, which means I'm going to set each one equal to 0 separately and solve for x. So I got to add 9 here, add 9 here, cancel, so x is equal to 9. Subtract 3 from both sides, cancels, so x is equal to negative 3. So like the other time, if x is 9, if I plug in 9 up here, I'm going to have a big 0. Any number over 0 is undefined, so I do not want 9 in my answer. So anything but 9. Same thing goes with the negative 3. So everything but negative 3. So that would be answer choice B on your booklet. So you want every real number, any number in the world but 9 or negative 3. Any questions? Christine, everything good? Okay, how about you, Josh? Good? You're good? Okay. So, okay, if you're really, really good, Christine, write kapow. And you have to write it right. You need to learn how to spell kapow. And don't Google it either. All right, I'm going to move on. Okay, I'm solving the system of linear equation, and they specifically ask me to solve with substitution. Wouldn't have it any other way. Substitution means that I will solve for one variable in one of the equations and plug it on the other one. But this one is already halfway done for us. It's already solved for x. So what I'm going to do is get the contents of x and plug it in right here. So I'll have -7, open big parenthesis here and plug in all this, just dump it in there. Did she spell kapow?
Oh yeah, Kapow.
Oh man, she got it. That's nice. Okay.
Well, she definitely going to graduate and be part of the
Definitely.
superhero team.
Okay, so now I'm going to solve this. So to get rid of parentheses, I'm going to need to distribute. Let's see if my helper would tell me what's -7 times -17. Oh, never mind. It's 119. Positive, and then -7 times 2y, that'll be -14y. Then I'm going to bring everything else down, get -17. Okay, so far so good. Then I have like terms here. I'm going to combine them. So I bring this down. I have -17y equals -17. Solving for y. Old news. Subtract 119 from both sides. Draw the line. Then I add these two. I'll get -136. Gotta get rid of this -17. Divide it on both sides. Cancels out. So y is equal to +8. Okay, I got one of my villains, should I call it. Now I need to find the other piece because this is supposed to be an ordered pair. So I got my 8. I go up here in either of the two equations. It doesn't matter, this one or this one. You step out of the box and you tell me which one is easier for me to plug it in. Can somebody tell me? In the meantime, I'm just going to go with my guts and plug it in on the top. Oh, there we have it. -17 plus 2. My y, that is 8. So now I have x equals to -17 plus 16, 8 times 2. So x is equal to -1. -1. Okay, I have a question. Okay, the question is, would I get or would you get the same answer if I plugged it into the second equation? Definitely, absolutely. Because
Christina answered it before you.
Christine, she answered before me. Well, you
It's
know,
more work.
it is more work, but you would still get the same answer.
Thank
Okay, you're welcome. All right, can we move on?
Yep.
Josh?
Josh says yes.
Okay. Solve the system of linear equations using the elimination method. Okay, so, you know, just so we don't get too bored, we used substitution last time. Now they want elimination. It's my choice. I can either eliminate the x's or the y's. So, I don't know. I'm going to pick Christine or Josh. Which one would you like me to eliminate, the x's or the y's?
Eliminate the y.
Ah, good choice. So for me to eliminate the y, I first look for a common denominator between 4 and 5, which is 20. So what I need to do is multiply the whole top equation by -5 and the whole bottom by 4. I get to distribute this -5 to every single term up here and the 4 to every single term down here. That looks like a muscle man, which makes sense because that's how my arms look like, chiseled. -35x, -20y, +30. Down here, I have 24x plus 20y. I expected that to happen because I wanted to cancel it. And negative 12 right here. So negative 35x plus 24 is negative 11x. And 30 minus 12 is 18. Divide by negative 11, divide by negative 11, so x is actually equal to negative 18 over 11. Now, this is a tough cookie. It doesn't matter where I plug it in, it's going to be a little bit not hard, but more work. So it doesn't matter. I'm just going to pick the smaller one because I guess it has smaller numbers. So I'm going to have 6, open parenthesis, negative 18 over 11 plus 5y equals negative 3. Negative 6 times, 6 times negative 18 is negative 108 over 11 plus 5y equals negative 3. I don't know. For some reason, I'm tempted to multiply everything by 11 because I don't want to work with the fractions, but at the same time, it's just one fraction, so I can deal with that. So I'm just going to add 108 to both sides. And can please somebody tell me what's negative 3 plus 108 over 11? What's the answer for that? Okay, get somebody here telling me it's 75 over 11, but I'm not finished. I have this 5 over here, so I'm going to have to divide by 5 on both sides. Dividing by 5 is the same thing as multiplying to its reciprocal, so I times by 1 over 5. I'm going to go ahead and cross cancel here, so 5, this is 1, 5 goes into 75 how many times? 5 goes into 75, 15 times. So now I have, let me just clean this up. I'm going to bring it over here. So now I have 15 over 11 times 1 over 1, which is a waste, but I'm still going to do it for clarification. So my final answer is 15 over 11. So my ordered pair is negative. Somebody's asking me to use a different color. I'm going to have to say no. Okay. You want to see the answer clearly? Okay, I guess dagger equation slicer Deanna doesn't have vision powers, supervision powers. Let's see. Is bright yellow good? No? Depending on how you were going to highlight it. Okay. All right. So let me pick. Ooh, see that? That's nice. Whoa. Yeah? All right. That'll do it. Okay. So that's answer choice C. Let me write C right here. That's bright enough for you. There we go. Question number 20. Let me just change this real quick before I hurt my eye. I'm still highlighting. Okay. I'll change it to pen. Huh? How's that? Good. Okay. So word problem. Solve this application by using systems of linear equations. There were 690 people at a play. I doubt that. Nobody goes to play anymore. The, the admission price was $2 for adults and $1 for children. Okay, the amount for the receipts, the total was $1,040. They want to know how many adults and how many children attended, assuming that the children pay the same price as the adults. Okay, so I'm going to use A for adults and C for children. Is that okay with everybody? Instead of X and Y, same thing. It's less confusing. A, adults, and C for children. So I have adults plus children from the people that attended. It was a total of 690 people. Then I have $2 for adults, right? Plus $1 for children, and that total 1040. I guess I could say that, $1,040. Okay? We're gonna use substitution. No, let's use elimination. I guess it's easier, right? So because the only thing I need to do is either if I'm eliminating the A, multiply by -2. If I was eliminating the C, I guess I'll have to do the same thing, right? All right, so then, right, then I'll have -2A minus 2C equals to 1380. Negative 1380. Draw my line, cancel. So here I get negative 1C equals 2. If I subtract these two, I'm going to get a negative answer, negative 340. I have this negative here, divided by -1. All right, so there were 340 children that attended. Now I could go back and plug my C right here. So I'll have A plus 340 equals 690. If I'm solving for A, I'm going to have to eliminate this 340 by subtracting it from both sides. So there were 350 adults. So adults and children. Okay, so I have 350, right? 340. Depending which one is first, I guess. I'm assuming that A is first. Because it's the first letter of the ABC. Yes, you're right. Okay, am I finished here? Are we switching over? Okay. All right, so question number 21 is gonna be with dagger equation slicer. Diana. Watch out.
All right. This one is using long division, my favorite actually. And I believe we did it like in the beginning of the semester, so I hope you guys remember how to set up a long division problem. So write the top equation, and then in front you're writing the divisor. So x plus 8. Okay, so up here gonna go your quotient, so you're gonna have to think of by what do you have to multiply whatever is your answer with this to get x squared. So the only thing that I can think of to multiply x by is another x to get x squared. So x times x is x squared. The first term always has to be exactly the same, and then I have to multiply that by the second part by the 8. So x times 8 is just 8x. I am going to subtract, which changes the signs. This becomes minus, this becomes minus. And then x squared minus x squared just cancels out, and positive 4x minus 8x is negative 4x. Bring down the next term. In my case, I only have one more term left, so bring down the last term. And the same thing. Look at this first one and think of something you will have to multiply the first x by to get to negative 4x. The only thing I can think of to multiply by is a negative 4, because negative 4 times x is negative 4x. Exactly the same, so this is correct. And then I multiply the 4 also by the 8, which gives me a negative 32. Again, multiplying both by a negative sign will switch all the signs. So this becomes a plus, this becomes a plus, and now when I add them down, both of them will cancel out. Negative 4x plus 4x is 0, and negative 32 plus 32 is also 0. My remainder is 0. So the quotient of this problem is x minus 4. And this is answer choice A on your packet. First letter of the ABC, A. Okay, any questions on long division? I guess not. Okay, factor the polynomial completely. Factoring. With factoring, there are so many things to pay attention to, but every time you see two terms and some kind of cube, you should think about sums and differences of cubes. And for that, you don't really need to know a method, but you need to know a formula. So for the difference of cubes, bless you, for the difference of cubes, the formula would be a minus b, and then a squared plus ab plus b squared. And if you have the version of the sums of cubes, the formula would be a plus b, and then the signs alternate. So minus first and then plus. So you see the difference has the minus sign first, then both positive, and the sums of cubes has positive first, then negative, and positive again. In our case, because it's a difference of cubes, we need the first formula, this one. So we just have to plug in. In this, the A basically represents just the letter M, and the B in our formula represents, I believe, which number multiplied by itself 3 times gives you 216. I know, Christine, you got it already? We're waiting on Christine. All eyes on Christine. Because the lecturer is kind of sleeping over here. That's what you get if you... Oh, the question was, what number you have to multiply by itself 3 times to get 216? So what's the cube of 216? Awesome, you got it. Did you use a calculator for that? Okay, never. That's okay. I mean, you're allowed to, so don't feel bad about it. I wouldn't have known that in the back of my hat neither. All right, so now when we know A and B, we're basically just plugging into the formula, and that should be really quick. We got M minus 6, and then M squared plus AB, so M times 6, which is 6M, and then plus B, which is 6. 6 times 6, so 36. There we go. If you look in your packet, this one, number 22, is answer choice C. There we go. So nothing complicated about it. The only thing you need to know is two formulas, the difference of cubes and the sums of cubes. Bang! That easy. Now, this one, I believe, also was on your last test, test 3. And for a lot of you, this is really hard to solve. So you have two options. You can do it the hard way by multiplying each side to get the least common denominator, or you realize, let me use this one. But obviously they are not the same. So I'm going to use 8 minus x, and I'm going to try to make it the same. I'm going to switch these two terms around to get negative x plus 8, but they are still not the same. Now I'm going to try to take out the GCF, and I can use a negative 1 as my GCF, so I'm going to take out a negative sign, and I'm left with x, and now the sign changes, negative 8. So right there, now my two denominators match, and the only thing I have to do is combine these two signs, where a negative and a negative are going to give me a positive. So I'm going to rewrite my problem just by doing this, instead of having to do it the long way. X minus 8, and this should also be an x minus 8, but I can combine it. So if I write it like this, then the fraction bar should not be completed. Okay, but you could also have done this by multiplying this side by x minus 8, and then this side by 8 minus x. That should give you the same answer, but it's going to take way longer because you're going to end up with two foiling problems and so forth. So this would be the easier way if you realize they are opposites and you can factor out a negative sign. So now all we left to do is combining the numerator, minus x plus 2x plus 1 all over x minus 8. So like terms, we have a negative x and 2x. That leaves me with just x. And then 2 plus 1, so x plus 3 over x minus 8. That's it. And in your packet 23, that's question number 23. This should be answer choice A. Okay. So remember, in my case, I used the shorter version, but you are welcome to multiply both sides to get the least common denominator of both of the fractions the same. Okay, moving on. 24, simplify the complex fractions. So I guess we're really into fractions here. And write your answer in lowest terms. When I see a problem like this where multiple fractions within each other, the method that I would choose is find the least common denominator of all four fractions, and you can make this a fraction as well, and multiply each individual term by that least common denominator. So looking at the denominators, tell me what is the least common denominator. I'm going to give you 2 seconds to do that. 2, 1. You're very welcome. Okay, you distracted me from counting. You got the LCD, Christine? 2, 1, 2, 1. What's the LCD of all the individual fractions? You got a 1, you got an x, you got a 3, and a 6. Okay, 6 is good, but what about this x? Okay, 6x, that's good. So if you look, each individual fraction will go into the LCD. The 1 goes into there, the x is in there, the 3 would go in there 2 times, the 3 would go in there 2 times, and the 6 is in there 1 time, so we're good. This is our LCD. What we're going to do now is we're going to multiply each individual fraction by the LCD. So 6x, and this side by 6x, and over here 6x again, and last time 6x. So what happens now is that the denominators are going to cancel out. This one doesn't cancel out because it was a 1. So we have to straight multiply our leftovers. 6x times 4 is 24x. And over here, the x in the bottom cancels with the x on top. So we have 6 times 2, which gives me a 12. So the denominators are gone. And then over here, the 3 reduces with the 6. So both of them are divisible by 3, which leaves me with a 1 in the bottom and a 2 on top. So 2x times x gives me 2x squared. And over here, the 6 cancels with the 6, and all that's left is multiplying the 1 by the x. So plus x. So now it looks much nicer by multiplying by the least common denominator to get rid of all the denominators. And now I can check if there's anything else I can do. So if I look at both of these terms, I see they have a greatest common factor. And the greatest common factor is 2, 1, 0, 2. Christine, we're waiting for your response. You are our superhero star today. What is the greatest common factor of the numerator? 2 is, okay, 2 is some factor but not the greatest. 12 is a better choice. 12 is correct. So you can take out a 12 from both of these and you are left with 2x plus 1. What about the bottom? Do you see a greatest common factor in the bottom, in the denominator? X, very good. They both share an x, so we take out an x and we are left with 2x plus 1. Now, look at that. They are exactly the same, so bam! Yes way. They yes way. Okay. And everything that's left is 12 over x. Looking in your packet, this is C. That's what I was saying, C. Okay, C. One more on my part, and then it's Vanina's turn again. Here we go. This problem also from your test, and this time it's a slightly different version, but it's definitely giving you guys a hard time. So let's read it first. Solve an application of a rational equation. Glenn and Paula want to dig an irrigation channel for their newest garden. Together, important, it takes them 1.8 hours to dig an appropriately sized irrigation channel. If Paula can dig, so Paula can dig the channel by herself in 2.7 hours, how long would it take Glenn by himself to dig the channel? So if necessary, we have to round, but we can check that at the end if we have to round. So this is a rational equation application, which should always look something like this. You have the total time or total work of both of them together, and then you have the part of the first person. So let's say first part. And then you have the total time together over the second part or second person, whatever the problem says. The wording just going to be the same, but the setup, the wording is going to be different, but the setup is always going to be the same. So you have the job of one person adding the job of the second person, and you should get one complete job. Last time we set it up differently, which is also a way, in our last study session to do it, but this one pertaining to this problem, it is much easier. So the total time, we got it here together, it takes them 1.8 hours, goes for T, 1.8. Then the first person or first part, what do I see here? I see Paula, so she could do this on her own in 2.7 hours, goes right here. And then again, the same total time together will be this, and the part that Glenn could do, we don't know, so we can use the variable x, and all that equals the one complete job. So setup complete. Now what's left to do is solving it. Remember, we're solving for x, so we could multiply through by the least common denominator. Least common denominator, what is it? 2, 1, 0. We got something?
Yes, she got it.
What is it?
2.7.
Good job, because this is most of the time the hardest part to find the least common denominators of multiple or rational fractions. So we're going to multiply each individual term by the least common denominator, 0.7x, and also the last one, 2.7x. In this case, the 2.7 will cancel out, and I'm left with x times 1.8, which is 1.8x. And then over here, the x cancels with the x, and I'm left with 2.7 times 1.8. And if you do this on the calculator or in your head, you should get 4.86. That's it. And the last one, well, nothing cancels out. There is no denominator, so 1 times 2.7x is just 2.7x. Now this problem already became simpler. We are solving for x, so let me subtract 1.8x from both sides. Psychic, what is that? 4.86 left on this side equals 0.9x. Okay, last step, I'm running out of space. Last step is to divide by 0.9. So x equals 5.4, right? Okay, my sidekick says it's 5.4. Pertaining to the problem, this means hours. And we got some responses from our audience, so it must be 5.4. If we all get the same, definitely is 5.4. So this is means hours. That means Glenn by himself takes 5.4 hours. Let's just compare real quick who's working faster. Wow, okay, rock on Paula. Paula is doing it quicker than Glenn. She definitely should join the superhero squad. Okay, so this is your answer, and the letter that you have to choose is 25C. C, there we go. All right, last switch. Coming up is superhero Vilectra with question number 25. 6 plus 1, 25 plus 1.
25 plus 1, that's what she meant. 26. All right, let's go to the next question. All right, number 26, rationalize the denominator and simplify. Okay, when you rationalizing the denominator, if you only have one term, normally, if you have a term with a radical, you're not supposed to have radical on the denominator. If you only have one term, you probably would be multiplying by that term. But if you have two terms, you have to multiply by its conjugate. The conjugate simply means you change the second sign to its opposite sign, which means we're going to be multiplying top and bottom by square root of x plus 7. Same thing here, square root of x plus 7. So all we left to do up top, let me put it in parentheses just so you see that I'm going to distribute, not that I have to put it in parentheses. So I'll have negative 5 square root of x minus 35. Bottom part, ooh, I made a mistake and nobody told me anything. It's -7. Glad I caught myself. You are demoted. You are not the sidekick of the sidekick anymore. You're going back to wannabe superhero. Okay, so -7. So this is plus 35. Okay, remember what we said before? If you do this long enough, you're going to notice that the middle term cancels, which means, yes, instead of FOIL, it's FL. Say it with me, FL. Okay, FL, which means square root of x times square root of x is just going to be x because it's square root of x times square root of x is, let me put it on the sides, times square root of x is going to be square root of x squared, which these two cancel each other out, leaving us with just x. So that's why I got this x. And then this is going to be negative 49. Like, you could go ahead and try it on your own, but I think you should give me a vote of confidence here. I know what I'm saying. Okay, and that is your final answer. I believe in your is answer choice B, but in your booklet, the two top numbers are switched this way, which makes no difference. It's still the same number because the 35 is still a positive 35 and the negative 5x is still a negative 5x. Any questions? Okay, so let's go to question number 27. Wow, that looks like a lot of work, but I'm going to tell you right now, it is not. Same thing. First, distribute here. The rule is when you multiply exponents, what do is you add the exponents. So I'm going to times 2 times 3 gives me 6, and then I have x negative 1 over 3 plus 3. 2 times negative 1 is going to be negative 2. I'm going to have x again, negative 1 over 3 plus 1 over 3. I'm going to do this part here on the side. I want to keep my board clean, so I'm just going to do this part over here. They don't have the same denominator. Put it over 1. The lowest common denominator is 3 times by 3, both top and bottom. So I have negative 1 over 3 plus 9 over 3, which gives me 8 over 3. So just like that, this side is done. X 8 over 3. Now right over here, as we can see, negative 1 over 3 plus 1 over 3 cancels, so I have a 0. And can anybody tell me what's x, any number raised to the 0 power is? X or anything. Yes, it is. 1. 6x 8 to the 0 power, so now we have negative 2 times 1. So my final answer is 8, 3 minus 2, and that is answer choice. I have a question up here, but in the meantime, I'm just going to say that's answer choice C. What is the question?
Okay, Christine wants a second chance to be promoted again.
Okay.
So ask her what is Velectra Vanina raised to the 0 power.
Okay, so I've heard, Christine, that you want to be get back to be promoted to sidekick of the sidekick. So my question is, what is Velectra Vanina raised to the 0 power? You have 1 second to answer. 1. What is it? Okay, all right. So you again, the sidekick of the sidekick. Let's go. Next question. If there are no more questions for this slide. All right, so I'm going to go to number 28. Okay, solve and check the solutions. I'm going to go ahead and cut this in half because I'm going to solve here and check the solution over there. Okay, right over here, off the bat, I'm trying to get rid of this a radical. First thing is first, I'm going to go ahead and square it. If I square one side, I have to do the same thing to the other side. Any negative number square is going to be positive, so I don't need to worry about it. This cancels out, so I'm left with just 7y plus 8 equals 64. Solving for y, subtract 8, so 7y is equal to 56. Divide by 7 real quick. Y is equal to 8. No, I'm sorry. Yes, it is 8. All right, everything is good. Now, I have to check. Every time that you start a problem and it has a radical, you have to double check. So I'll go back to the original. Let me erase it real quick. All that stuff that I put up there. Okay. Go back to the original. That's where I'm going to plug my answer. So I'll have negative 7, 8 for y, plus 8 equals negative 8. Whatever I get here has to equal this sign. If it doesn't, this is not a solution to this problem. Let's see. So I got 56 plus 8 equals negative 8. 56 plus 8 is 64. Square root of 64 is 8. I'm bringing down my negative 8, and yes, it is a solution. A valid solution, should I say. Any questions? Nope. All right, moving on. Question 29. Oh man, beautiful. I love factoring. And okay, let me see what's going on here. Yeah. Okay, so first thing that I'm going to do is check if everything is written in descending order. Yes, 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 yes. Next thing I'm going to do is flip this already so I don't have to worry about it later. So I'm going to have x squared minus 100 over x squared plus 4x plus 4. Change this to multiplication and flip it. The old keep, flip, copy, change. It has so many names. I don't even know. I stop at copy, flips it. Oh, KFC? Never heard that. Okay. KCF? Which one is it? KCF. Oh, okay, I get it. Keep, change, flip. Okay, so here we're going to factor, and see if we can cancel anything. Right here, I notice that I have a perfect square here and another perfect square. That calls for a difference of two squares. Signs are flipped. Square root the first term, split it. Square root the second one, split it. That's it. This one, trinomial, leading coefficient 1, looks like a perfect square to me, perfect square trinomial. So I'm going to do this anyways. X plus 2, x plus 2. Right over here, same thing. Trinomial, factor x here, plus and plus, factors of 2, that gives me 3 or 2 and 1. Right here, what are we doing here, guys? Is that a difference of two squares? No, because this is a plus sign. It can be difference if it's plus, but we always look for which method are we looking for here? Which method are we going to use? Anybody? Somebody from the audience? Yes, from the heroes, superheroes wannabe. Yes, I am. Factoring out a 5. Very good. All right, so like I said, I did the flipping in the beginning, so I don't need to worry about it. I'm just going to go ahead and start canceling vertically or diagonally, never horizontally. That goes away. So my final answer is x minus 10 over x plus 2 times x plus 1 over 5. I can rewrite it this way. X minus 10, x plus 1, conventionally 5 first, x plus 2 as my final answer. Okay, can I move on? All right, question 30. All right, so I'm going to take about 5 minutes or so because I have about 3 ways of doing this and I want to show you all 3 of them. Are you guys up for it? No, okay, never mind. I'm just going to show 2 ways, one in the calculator and the other another easier way to do this. Okay, so I'm finding the vertex. Remember the vertex, the formula to find the actual vertex is this one, f of negative b over 2a. This only means that I'll do 2a, and whatever I find, I plug it in the f function to find the y. Because hk is the same thing as xy. They just call it that way so they can differentiate it from it being the vertex of the parabola. So I have negative b over 2a. So this is my b. So I have negative 2 over 2 times 1. So that gives me negative 1. That was just this part here. That's what I found. Now I need the other part, so I go ahead and plug it in here. So I go back to the original. I have 1 squared, negative 1 squared plus 2 times negative 1 minus 8. Well, negative 1 squared is just 1. 2 times 1, that's, negative 1. That's what I meant to say. Erase. Whoa, you saw that? I erased the plus to a minus. Those are called skills. Pen, minus 2 minus 8, and that's equal to negative 9. So So 1 negative 1, 9 is my vertex. And that's it. However, I just wanted to show you real quick how to find it on the calculator. May I? Okay, let me escape here. Keep the drawing. All right, there we go. Let me erase this real quick. I forgot how to erase that. True. Clear. All right, so we can just go ahead and put this on our calculator. X squared plus 2x minus 8. Okay? And then if you look at this first, the leading coefficient is positive, which means the parabola opens up, meaning we are looking for a minimum. So if you do second trace, you go 3 for minimum, okay? Then it says, okay, left bound. I go anywhere on the left bound of the minimum. That's fine. And I press enter. Then I go again anywhere on the right bound of the minimum. I press enter. Then it tells me to guess. I press enter and it's right here, negative 1, negative 9, which is the same thing we found before. Okay? Oh yes, it's true. If you cannot see the minimum well, you're going to need to adjust the window. In this case, it looks like if I brought the Y min a little bit more down, I'll probably see it better. So if I go, and I wanted to leave the scale at 1, but never mind. So my Y min, let's say my Y min is negative 15, I guess is fine. And let's graph it and see. There we go. You can see it better this way. And then you repeat the same steps. Second trace, and to the left of the curve, to the right of the curve, and then hit enter, and it'll give you the same answer. Okay? Or, no, I'm not gonna. There's way too many ways to do this. This is enough. Okay, so I'm gonna hand it over to DAG equation slicer Deanna, so we can finish this up, and thank you for participating.
Oh, this question 30 is answer A on your packet. A. There we go. All right, these was all the questions that you needed to know to be prepared to take your final exam. Kapow! All right, don't get scared, but here's some important information. This is the final exam info. Again, you had submitted some preference requests throughout the semester, so this will be your testing location, whatever you were approved for. Obviously, whatever I got on the slide is only from the Osceola campus, but the day and the time will be the same. The final exam for you will open April 20 and will be opened, stay open until April 27. April 27, which is a Monday. Can you check first? Monday or Tuesday? I think it's a Monday. Yeah. The 27 is a Monday, so make sure not to wait until the very, very last minute to take your final exam, because you never know what could happen. And there will be no retakes or anything like that, no excuses, no nothing. This is your one and only shot. So even though it is open on that Monday, the 27th, 7 p.m., check with your testing center until what time the testing center is open. And remember, you have to be 2 hours before the test. Things that you might need is your graphing calculator, especially now where Velectra, Vanina showed you guys a lot how to use it to your advantage. Then you might need pencils if you can't do the things in your head. You will need your VID photo ID, otherwise you won't be let into the testing center. The CRN of this course, good to know, because that's how the testing center can identify your class, is 22524. This course is MAT1033C, and I'm the instructional assistant, Diana Budach. Your actual professor is Dr. Pedoni. So either one of those names should be good to permit you or find the test you're supposed to take. And here are the testing center hours for the Osceola campus. I am going to stay online for a little longer just in case anybody else has test questions. Please study. Please finish up your last homework sections and evaluations. And you can email me, contact me throughout the week until the final exam, until the very last day, if you have questions, need help. And thank you so much for attending today's online study session. And special thanks to Christine, who was an awesome supporter, participator, and superstar sidekick, who was promoted to superhero level 1 backup. Have a good day. Very good. Kapow. This is the end of the session. And you guys take care. Good luck. And all the above. Bye. Kapow.